Good afternoon, and welcome to Georgia DNR's Lunch and Learn webinar. I'm Emily Wingo of the Georgia DNR Floodplain Unit. First, a little housekeeping. We are in listen-only mode, so please make sure your mic is muted. If you're having any Wi-Fi issues, you may want to turn off your camera and any other programs you may have running. Please make note of the chat feature on your screen. Please use the chat for all communications as we will not be taking questions by audio. Aaron Kyle of Dewberry is monitoring the chat and will try to help you with any technical matters. We are offering 1 hour of continuing education credit for CFMs. To receive credit, you must be logged in separately, answer all poll questions during the session, and provide your name and email at the end of the presentation. Please use the radio buttons to respond to the poll questions in either the pop-up window or in the chat box. A copy of the presentation will be emailed to all attendees. Also, a survey link will be provided at the end of the presentation. We appreciate you completing the survey so that we may improve these webinars in the future. We are recording today's webinar and plan to post the video to georgiadfirm.com. With that, let's get started. Today's presentation is 2D base level engineering models assist the state of Georgia with Hurricane Helene post-disaster recovery. Our presenters are Nick Jones, Senior GIS Professional, and Kevin Slover, Associate Senior Scientist with Dewberry Engineering. Nick Jones is an experienced GIS specialist with over 20 years of GIS experience working to support hydraulic engineers and hydrologists. This experience includes completion of several flood risk projects from start to finish. He is an expert user of Esri products for digital terrain modeling, mapping, analysis, and AGOL website development. Kevin Slover is a senior coastal scientist. He's been with Dewberry for 20 years, specializing in storm surge, modeling, high-resolution topographic and bathymetric data, and hydrometeorology. He has recently been working with quantitative precipitation estimate datasets to hindcast historical flooding events in Louisiana, Florida, Georgia, and North Carolina. And with that, I'll now turn it over to Kevin.
Thanks, Emily. Good afternoon, everyone. We're going to kind of step through, I guess the next slide will show kind of our outline for today. So the agenda for today is we're going to kind of look at base level engineering overview, where it's occurred in the state and how we can leverage the products from that. Look at incorporating actual storm data into our models. Obviously, this one we're looking at Hurricane Helene and the flooding that came from that. And then how do we use this model data and the storm data to make more informed decision using our web-based viewers. So base level engineering is currently completed for everywhere on the right-hand side that you see in blue. To date, we have 25 Huckgate watersheds, and then also 25,700 miles or so of streamlines that we've completed. You can see the list of the actual Huckgate watersheds on the left, and those correspond to everything in blue there on the right. So our case study, and it was one that kind of hit close to home, obviously, for everybody, was Hurricane Helene. Made landfall in the Big Bend region of Florida and then progressed northward before eventually turning to the northwest as it hit the South Carolina line. So it did come into Georgia in the southern part. There were Category 2 winds recorded down south in the Albany and the southern areas of the state, and up to 15 inches of rain, and there might be isolated pockets higher, 15 to 16 inches fell in Georgia. The map on the left, you can see kind of where the areas are. So Augusta obviously got one of the higher rainfall totals. They're looking at almost 15 inches of rain, but there was a separate pocket over the Atlanta metro area, as well as the Northeast mountains that saw, in excess of at least 12 to 13 inches of rain. So it was definitely a high precipitation event. The middle image is just kind of what the storm looked like during landfall, just to kind of give you an idea. And then the right image is that visible satellite imagery as it was making its way over Georgia. So one of the data sets that we can use is what's called MRMS, and this is what's the quantitative precipitation estimate. This comes from NOAA's National Severe Storms Lab, and it is, of course, an acronym, and I always love to say this on presentations, but NOAA does not actually stand for the National Oceanic Atmospheric Administration. It actually is National Organization for the Advancement of Acronyms. I've had full sentences with people in acronyms, and everybody gets it that works for NOAA. But MRMS actually stands for Multi-Radar, Multi-Sensor. And basically, what it takes in is all of your radar information from the various radar sites, surface observations, satellite observations, and numerical weather models. So you have high resolution, you have short models, long-term models, medium-range models. It ingests all that and then has certain algorithms that it'll use. And what it does, it tries to compute from that radar data what the actual precipitation amounts. So it'll look at amount as well as how much is falling, so that precipitation rate. For Hurricane Helene, we used a 48-hour rainfall, more when it made landfall, just when it made landfall into Georgia, I should say, to when it exited Georgia, and we made sure we captured the total precipitation that fell within the entire state. So what we did is we have all the 2D BLE models that I showed in the first graphic, showing where we had all the different models that we could use. This is what it actually looks like within our HEC-RAS hydraulic model. And what you can see, this is the entire state of Georgia. We can now see, similar to the other graphic, you can see within the model the banding and the different locations where that higher precipitation amount is. The purple is the higher rainfall. And then when you get into the green, that's kind of the lower rainfall. And then your dark reds and oranges are kind of in the medium, that 4 to 10 inch range. So we used it, and we you can see one of the example watersheds that we have. It's highlighted just to the south of Macon, in between the Macon and Georgia-Florida border. That's just one of the models that we were using. Thanks, Nick. To do all this analysis and produce depth grids, water surface elevation grids that we can then use, as Nick will present later on, kind of how we gathered and got to those risk map products. So one of the other things is post-storm activities, and this was kind of why Georgia DNR, as well as other folks, were very curious about what these results look like. The local floodplain managers, as everybody knows, is responsible for regulating all development in the special flood hazard areas by issuing permits and enforcing local floodplain requirements. The other key aspect that floodplain managers must do is perform those substantial damage assessments. So once a major flooding event takes place, they are required to assess all buildings within that SFHA to look for substantial damages before repairs. And the quote unquote definition of substantial damages is repair costs that is greater than or equal to 50% of the market value of that structure. So Georgia Floodplain MAP program, they inform the communities of their SDA responsibility. They provide support to local floodplain managers with those assessments. GEMA, Georgia Emergency Management Agency, assess damages and assist in mitigation actions, assist with the floodplain mitigation assistance applications, and then you have, of course, FEMA, and they provide aid to local floodplain administrators and individual business homeowners. So you can see on the right, we have the graphic where the emergency was declared. That's in the hashed, black and white hashing. Counties with the heaviest rainfall, we've kind of highlighted here in that blue, and then counties directly along that path, just to kind of show you how everything spatially lays out, are highlighted in red.
Hello, I'm Nick. I'm going to take it from here. I'm going to show you some storm data informed web-based viewers, but a little background before I do that. Some of the advancements that the Georgia Flood Map program made that allowed us to do this. You can see this list here on the bottom right, but we were able to leverage data sets like depth grids and probability grids. And then also we had, as Kevin had mentioned, we had 2D BLE modeling for a large part of the state. I want to say probably roughly half. And we also had footprints that we were able to categorize with this data. So this is the first viewer I'm going to show you. It's called the Hurricane Helene Inundation Areas based on BLE. I think we're going to send out the slides, and the link to it is here. But this is the page as it looks when you first get to the website. You can see that there's a sort of county boundary file here in the map. And these are data, these are areas where we had data that we were able to leverage for this. And over here on the far left, it was part of the challenge of this was knowing where to start. So we created this table here on the left. It's showing total buildings potentially affected by Hurricane Helene. It has in the far left here column, it has the county name, and then it's actually sorted by the total buildings. So we intersected buildings with our BLE modeling for Hurricane Helene, and this is a count of the buildings that basically are affected by Hurricane Helene according to our approximate study. And the maximum depth. So this is showing basically one of the buildings had this much depth of water according to our modeling, and that's the highest value that was shown. So the first thing you would do on this map is kind of look at the data and decide where you want, look at this table and sort of decide where you want to start. I kind of keyed in on Toombs County. So if you click Toombs County, the first thing that happens is the map zooms into that county, and it also starts to populate numbers here on the top. These are buildings that intersect the flooding but fall into certain categories. The most severe is greater than 8 feet of depth, and we're showing 5 buildings within Toombs County. And then we have 2 buildings between 5 and 8 feet of depth, 54 between 2 and 5, and roughly 1,500 buildings with less than 2 feet of depth. It also filters this similar table underneath here. These are the communities within Toombs County. You might see that it's basically the same table, but it's the communities as opposed to the counties. So if we wanted to further filter the data, we could click something like Vidalia here. And that does the same thing. It zooms into Vidalia. So you're getting closer and closer. And what happens is some layers will turn on or off based on scale. So since we're closer now, we're able to see buildings, and we're also able to see the Hurricane Helene flooding based on BLE and the Georgia community boundaries. It also starts to populate the table down here, which is similar to this table up here, except that this is the community. So this is showing Vidalia counts, which is really a subset of the county. So we have 19 buildings that are between 2 and 5 feet of depth, and we have 854 buildings that are less than 2 feet of depth. You can also filter it further. A lot of the FPAs really only want to see buildings that are within the SFHA, the Special Flood Hazard Area. So if you wanted to see that, you could click yes, and it would filter all these numbers and buildings even further. Over here on the far right, we have an actual table here that is the individual buildings that these counts are sort of counting. It just shows it's sorted by approximate depth, and these are the buildings within Vidalia. And if you click on one, I clicked on this one here, it will zoom into that particular building, and a table will pop up with more information, really data we already know. It's showing 4 feet of depth. It's in Toombs County. It's in Vidalia. And if I wanted to, I can sort of truth the data a little bit and click here, and it will take you to assuming it's available, it's not always available, we could take you to a street view of that particular building. And you can see here that it's actually this building here that's right next to I believe that's the Vidalia High School football field. And you can see that the ground around it is higher, so that's probably why this is getting picked up as being flooded or potentially flooded. The next viewer is called the Approximate Probability Based Dashboard for Hurricane Helene. This is where we leveraged probability grids and depth grids that we already had for these areas, the ones that are highlighted in black here. The underlying Georgia image that you see is the rainfall that Kevin talked about earlier, but it's broken down into events. So we took the amount of rainfall and we use that to categorize it as an event. So the dark red areas that you see are 500 to 1,000 year, and that's based on, and then the bottom of the range, 1 to 2 year, this yellow area down here. So where you would begin here is I would probably zoom into an area that's red, and then click anywhere in the map or on a building, and it'll kind of tell you if you can't tell the color, there's I think the human eye can only see 6 colors or 6 variations of the same color. But if you click here, it it'll kind of give you an idea. So this area, this red area, is showing a 500 to 1,000 year event based on rain. So if you from there you would click this button in order to save space. We made a lot of things on this map collapsible or toggleable. So if you click here, it opens up a menu of filters. So before we were seeing that according to this image underneath that there was roughly a 500 to 1,000 year storm. So you would in this case you have the option to delineate that particular floodplain based on probability. So over here I could type in anything between 25 and 500 in increments of 25. You may also think that even though the data is saying that there was a 500-year event there, that you just from personal experience, you know that like that was probably not a 500-year. Maybe it was a 100-year. You can choose whatever event you want here and type it in. The way we calculated that, we use the probability grids. So basically, the probability is showing anything inside the 500-year, the percent annual chance that that area will flood. And for example, if it's say a 500-year flooding event, that's 0.2% chance. So 100 divided by 0.2 equals 500. So that's what we did. We divided the probability grid by, or I'm sorry, 100 divided by the probability grid gave us events, and then we ranged those events from 25 year to 500 year in increments of 25. So back to this, you type in 500, then you would pick a county. We were looking at Columbia County, so I selected Columbia County, and it was actually unincorporated areas. So I selected the unincorporated areas, and you don't have to use this, but if you want to zoom into a particular stream, you can search for it, or you can just click this here and there'll be a drop down. I picked Crawford Creek, which is this stream right here going through the middle. So once you fill all this out, this data over here becomes populated. And this is similar to what we saw on the previous viewer. We have two columns of data, and they're showing approximate Hurricane Helene building counts. The column on the left is for Columbia County, based on the filter over here. And the column on the right is Columbia County unincorporated areas based on the filter underneath that here. So for example, there were 138 buildings with less than 2 feet of depth in Columbia County. And down here on the farther or on the more severe end, greater than 8 feet of depth, 56 buildings. And looking at these two columns, you can see that most of the buildings are in unincorporated areas. There's only one of all these counts that fell outside of the unincorporated areas in a different community. It also filters this table down here. These are the buildings within the selected event, county and community. So the buildings that fall within these filters. You can click on a building here, or you can click on it in the map, but just a little bit about the table here. The minimum event is 25. So we intersected the buildings with the probability to calculate the minimum event. And then in order for the filter to work, we rounded it to the nearest 25-year event. So everything that's within 25 years is going to, like anything that's under 25 is going to show up as a 25 as a minimum event. Say if it was 48 or something, it would show up as a 50-year to minimum event. We also have the percent annual chance, which is 20, which is why these two numbers don't totally agree. 20% means it's basically a 5-year event, but like I said, we rounded to 25 for the filters just to make the data more functional. Then we have the percent 30-year chance, a 0.2% depth, and then some other events as well. So I can click on a building in the table, or I can actually zoom into a building and then click on it in the map. So in this case, I zoomed into this building on the map and clicked on it, and it opened up this table for the building, and it's similar to what you see down here, but it's showing the minimum event, 25, as I explained. The 0.2% depth is 21.7, and then it's got some other depths that I was able to filter as well. And then the same thing, you can click on the street view for this particular, and if it's available, sometimes in the rural areas, it's not always available, but if it is, you'll be able to see the street view of that particular building. So one thing about this particular viewer is there's actually sort of two sets of everything. You can use that selected event map, which is right here that we just looked at, or you can click here and see the Hurricane Helene based on rain and probability. So this purple flooding that we're seeing, this doesn't require a filter to draw it. It's actually just showing you, it's showing you an intersection of that colorful raster that we looked at earlier and the BLE, and the probability-based floodplain. So like if the map, for instance, said that it was 500-year, it's just going to draw the 500-year, as opposed to you having to pick it from that filter. And you click here to open this map. And down here, this is a similar table to what we just looked at, but it's tied in more with this particular map. If you click this down here, the data is a little bit different. It's showing a range of events, and then it's showing a range of depths based on the range of events, and then some of the same data based on the depth grids. And since there's a different map, we needed a different legend. So you can click here, and it'll change the legend to the map that matches this particular map. And then you couldn't see this earlier because the menu was covering it, but these are just total counts of buildings based on those filters that we looked at earlier. These numbers will actually add up to these numbers. So this is the same data, but it's not broken down farther by these different ranges. So if you zoom into a map, same thing as before, you zoom into a building, you click on it, or you can click on it in the table. It brings up the whole table for this particular map or for this particular building. And the data is a little bit different because it's a different data set. It's showing some of the same things. The minimum event for this building is 25. The maximum event based on the rainfall is 500. So since the rainfall is saying there was a 500-year event here, and the building seems to think that it would take at least a 25-year to flood it. So that's why this building ended up getting picked up, because 25 is less than 500. Maximum depth of rainfall, 5.6, and that's just getting pulled directly from the 500-year. Since the range of events is 200 to 500, 5.6 is from the 0.2% depth, and then 5.4 is from the 0.5% depth. So that's where the range is coming from in the range of depths. And it has, again, the street view, percentile chance, percent 30-year chance. So this map, like I said, there's a lot here. So we tried to create more space. That's why everything is toggleable or collapsible in this case over here. Some other things that are on this map that are helpful. If you click down here, you can zoom in and zoom out with these buttons. Plus, if you want to zoom out, minus if you want to zoom in. And then up here, there are some more tools. In this box here, there's a legend that you can open up. It will match this, so you probably won't use this very often. It's a little bit redundant. I like to have the legend just on at all times, so that's why I don't use this very much. And then there's a list of layers that are available. You can see that this one's grayed out because it's scale dependent, so it turned off just because we're zoomed in pretty close here. There's no reason to see this. The layers that are currently on, the Georgia communities, the streams, the buildings affected by Hurricane Helene, the approximate floodplain, which is this purple floodplain. And then I have, if you see this image with the eyeball crossed off, that means that layer is actually turned off. So you can turn this layer back on if you like. It's the Helene rainfall that we saw earlier. You might have noticed that before there was like a street map on here, and now there's a imagery background. If you click base maps, you can switch between these. Like I like to default to streets, but then oftentimes you need base maps, so it's nice that you can or imagery. It's nice that you can just turn that on. Imagery hybrid. This is the same thing, but it's a lot of the streets and sort of important features are labeled. The last thing on here is this button down here. This is basically a reset button. If you click that, it'll just take you back to the beginning, reset all your filters, and zoom all the way back out to the state. So some of the recovery tool insufficiencies, BLE coverage, like you saw earlier, we only have about half of the state. So hopefully someday we'll have more, but that's definitely a limitation that we don't have it everywhere. Also, the BLE overestimates sometimes. Definitely, it looks like some areas are showing more flooding than maybe what happened. A lot of that is due to raster size. Like I think we use 10-foot cells, so that kind of overestimates just in that fact. Bing footprints aren't always accurate. You might have noticed in the image, some of the screenshots, that the footprints that we were showing compared to the imagery weren't exactly 1-to-1. But big data is free, so it's nice. There's not always an opportunity to use the news or social media to verify and improve mapping results. A lot of times on things that I've worked on, we've actually gone on, say, X or Twitter and found flooding that we could see in images that people have posted on the internet, and we can sort of verify it against our examples, but that requires time and people. So that's kind of a limitation if you don't have that to do that. Need funding to calibrate the results and train end users how to use the viewers and data. You can see I think the data is pretty straightforward for me, but definitely, if you haven't used it, you wouldn't probably know where to begin. So we need funding to train people and also to calibrate the results, like I mentioned earlier. And also, the one of the biggest limitations is that you need this data and the results in a hurry, and we don't currently have a central repository. And I know for this one, it was a pretty big effort to bring all the BLE models together, gather all the topo data, and then get that rain data from, I think Kevin created it, get the rain data, not created it, but he downloaded it, but bring it all in and then run the models. The models take time to run. It takes time to sort of crunch the numbers and everything. So it's always a huge effort and not a lot of time. Okay, so now it's time for a poll question. I think this is the question, but I think Aaron's going to actually put it on the screen as well. Who is
Yeah.
responsible? No? Okay.
Yeah. Sorry. You can read it.
Okay. Who is responsible for performing substantial damage assessments, SDA, after a disaster? A, GMA, B, GADNR, C, local floodplain managers, or D, FEMA?
So I'll just take a moment and pause here. I'm going to launch the poll now, but if you want to receive 1 hour of CFM continuing education credit, please answer the poll question. You can use the buttons in the pop-up. If it does not appear for you, please check the chat, and I'll just give a few moments for everyone to respond. Okay, maybe like 10 more seconds, and then I'm going to close up the poll. So it looks like most people responded with C, local floodplain managers, which is the correct answer.
It's always C. If you don't know, C is the best guess. I read that. So here we have just a list of some of the contacts. You see Joe Bardenenza, the state NFIP coordinator, Emily, who's here today, the community assistants, and then we have some contact or some people from GMA, FEMA, and Dewberry. And this is our contact information, Kevin and I. If anybody has any questions, feel free to email us. And that ends the slides.
Nick, I did have one quick question for you.
Sure.
You mentioned using Bing footprint data in this, and I know Bing footprint data tends to capture literally every building it can, including those storage sheds. Was there any portion of this where you tried to remove some of those smaller buildings that were, we presume were storage sheds?
Yes, that's a good question. We typically remove buildings that are less than 400 square feet. I think that we got that from, that's the average size of a garage. So yeah, we take out buildings, and there are actual houses that are that size now, but for the most part, I think you're getting rid of a lot of the buildings and sheds if you take out things that are 400 square feet or less.
Okay. Yeah. And the rainfall data that you picked up, Kevin.
Yes.
Could you repeat again where you got that?
That is sometimes hard to find, but if you go to the National Severe Storms Laboratory from NOAA, they will usually have links for that.
Okay, fantastic. If anyone else has a question, please throw it in the chat. Give you a couple of minutes because I know that's a lot of good information there. Curiosity, how long did it actually take to run that model, Nick?
I want to say I didn't run it personally, but I think it takes. We broke it down into watersheds. It wasn't all one model. I think it was Huck. I want to say it's Huck 10s, and Kevin might have a better answer, but I think the models take a few days to run.
Wow. We do have one question about how accurate was the flooding depth of the buildings?
Based on the modeling, or based on the BLE modeling, it's like we mentioned earlier, we don't really have the funding to sort of calibrate everything. So we were trying to get a pretty, general estimate of what was flooded, basically what was flooded, what was not flooded, and how severe it might be. I don't have an exact number. I can look more into that. I will say that the probability-based flooding is the first viewer that was based on the second viewer that was based on probability. That's just data that there's a wide range of quality because it's leveraged. Some of it's pretty old, some of it's newer. But as far as how accurate, I don't have a great answer to that question.
Okay. And Dennis, just so you know, yes, this recording will be shared. We will be posting it on georgiadfirm.com, and if you'll just look for that YouTube channel icon, it'll take you right to it. Another question, if local groups have data on flood levels, can that be submitted to help calibrate the model?
Yeah, I think anything would help. How practical it is to get it in time and everything is one thing, depending on how severe and how widespread the event is. But yes, I think that would definitely help if it's available.
Is it possible to insert the local tax data into the system to help with the substantial damage, substantial improvement?
I think it's possible. I don't know that we necessarily want that information on the viewer. It just opens up kind of a whole nother area of privacy concerns.
Okay. That's true. It does open up some strange issues. And any other questions? Okay. Well, thank you, Nick and Kevin, for that very informative webinar. I hope everybody's enjoyed this presentation as much as I have. I know I'll probably go back and listen to it again, but just because there was so much good information. We're going to keep the chat open, so just in case there's any other questions, we'll submit those over to Nick and Kevin for them to get back with you, but please be sure to include your email with that question. Please make note of the registration link for the survey in the chat and on the screen. Also, mark May 14th from 12 to 1 on your calendar for our next Lunch and Learn series. And the big part that everybody loves, we are offering 1 hour of continuing education credit for today's session available to certified floodplain managers that completed the polling questions and provide their name and email in the chat now. Again, a copy of the presentation will be emailed to all attendees. If you're requesting continuing education credits, those certificates will be emailed separately. Once more, our next Lunch and Learn is on May 14th from 12 to 1. So be on the lookout for that invitation. And with that, thank you again for attending today's event. If you don't have any other questions, this ends our Lunch and Learn for today, but please be sure to put those questions in. Thank you.
Thank you.
Emily, can you repeat where we can find this this recording once
Yes.
it's posted?
It will be posted on georgiadfirm.com. D is a Delta firm.com. And then when you go to that site, there'll be a little YouTube icon over in the top right. If you'll click on that, all the recordings for these sessions are available there on our YouTube channel.
Thank you so much.
We did have one other question that came up, Nick and Kevin, if you got a second. All or most of the counties shown on the post-storm activity slide shown in blue as highest precipitation would have been to the right or center of the storm, which is also where the emergency declared counties. Few counties left west of the storm track with high precipitation do not have emergency declared counties. Could there be a reason which perhaps is causing those counties left of the storm track? Is that
I'm not sure they're on anymore, but I can
Ah.
forward the question and have them get back to you, Andrew.
okay? All right. Well, thank you so much, everyone. Walter, did you include your email address? Will the whole state eventually be put in the BLE system? Well, that's a Joe Martinenza question if I ever heard one. There are some counties that the data has, or the BLE data is being reviewed and will be uploaded soon. But at this time, the BLE data is primarily for those areas that have A zones, and not so much the ones that have the model-backed A zones, like in the metropolitan Atlanta area, as I understand that. Ryan, did I have that one correct?
Yes, that's correct.
If there's no more questions, I can close out the meeting.
Okay, great. Thank you so much. Y'all have a
Thank
great
you.
afternoon.
Thank you. Bye.
Hi, Emily.